Hello friends, welcome to Aravali Geo Academy. Today we are going to discuss mineral aragonite and mineral vaterite. So this is the mineral aragonite and this is the mineral vaterite. In previous lecture we have already covered mineral calcite. So we already know there are three polymorph of the calcite. One is the calcite, aragonite and vaterite. Okay, all are the polymorphs. Polymorph it means same chemical composition but different crystal structure. Crystal system is different but chemical composition is the same. Okay, so there are three polymorph. One is the calcite. Calcite crystallize in the trigonal crystal system. Then aragonite. Aragonite crystallize in the orthorhombic crystal system. Then vaterite. Vaterite crystallize in the hexagonal crystal system. Okay, and vaterite is the rare and unstable polymorph. Now we are going to discuss the physical property of the mineral aragonite. Number one, chemical formula. Chemical formula of aragonite is CaCO3. Then crystal system. Aragonite crystallize in the orthorhombic crystal system. Then color. Color of aragonite is colorless, white, gray, yellow, green or blue. And we already know color depend on the impurity of the trace element. But in this slide, there are two important points for the upcoming exam. One is the chemical formula and another is the crystal system. Remember the two important points. Next, streak of the aragonite is the white. Then luster. Luster of aragonite is vitreous to resinous. Then transparency. Transparency of aragonite is transparent to translucent. Then hardness. Hardness of aragonite is 3.5 to 4. Hardness is very important because aragonite is harder than calcite. Okay, so in this slide, the 7 point is very important. Hardness. Hardness of aragonite is 3.5 to 4. Now cleavage. Cleavage of aragonite is distinct on 0, not 1, not direction. Okay. Then fracture. Fracture of aragonite is subconchoidal to uneven. Then specific gravity. Specific gravity of aragonite is 2.93. Then tenacity. Tenacity of aragonite is the brittle. Then twinning. Twinning is very important. Aragonite is example of the cyclic twinning. Okay. And also remember the crystallographic direction 1, 1, not. See, this is the cyclic twinning in aragonite. Okay. So in this slide, this is very important for upcoming exam. Aragonite is an example of the cyclic twinning. Next one, optical property of mineral aragonite. First is the optical character. Aragonite is biaxial negative mineral. Then refractive indices of aragonite is for ordinary ray 1.550, for extraordinary 1.650. And birefringence of the aragonite is 0.155. Okay, this is the very important point. Okay, so in this slide, this one is very important. Aragonite is biaxial negative mineral. Okay, and 2B angle of aragonite is 18 to 19 degree. And dispersion of aragonite is the weak. Extinction is the parallel. Aragonite is example of the parallel extinction. Ultraviolet fluorescence. So remember, the fluorescence color of the aragonite is white, blue or blue violet. Okay, and aragonite is also example of the fluorescence. Next, geological occurrence of the aragonite. Number one, aragonite is the high pressure polymorph of the calcium carbonate, and we already know calcite is the most stable polymorph of the calcium carbonate, and aragonite is the high pressure polymorph of the calcium carbonate. Okay, first see this graph. In the x-axis this is the temperature and y-axis this is the pressure. So aragonite is stable in the high pressure conditions only. Okay, in the surface condition, okay, or in high temperature conditions, aragonite is the unstable. Okay, and calcite is the most stable polymorph of the calcium carbonate. So as such, it occur in the high pressure metamorphic rock, such those form at the subduction zone. So high pressure available in the subduction zone. So aragonite is stable in the subduction zone areas, okay, not in the surface conditions. Aragonite is metastable. In surface condition, aragonite convert in the calcite, or calcite is the stable polymer. Okay, so this slide is very important for the upcoming exams. So remember, aragonite is the high pressure polymorph of the calcium carbonate. Aragonite occur in the marine and freshwater environment as a precipitate. So in aragonite formed through the process of the precipitation in the marine or freshwater environments. And aragonite also found in the cave deposits as a speleothem, or aragonite is the composition of the stalactite or stalagmite. Aragonite also found in the hot spring deposits due to the rapid precipitation. Aragonite present in the biogenic material like mollusk shell and the coral skeleton also. Aragonite also formed through the process of the evaporation as a evaporite deposit and associate with the saline lake or the lagoons. So aragonite also can form in the oceanic crust through the hydrothermal alteration process. Okay, now we are going to discuss about the mineral vaterite. Vaterite is the another polymorph, and this is not important, but chemical composition and some points are important. So vaterite is the mineral, a polymorph of the calcium carbonate. Okay, the vaterite named after the German mineralogist Heinrich Vater. It is also known as the mu calcium carbonate. Okay, this point is important. Which carbonate mineral is known as mu calcium carbonate? So vaterite. Then vaterite belong to hexagonal crystal system. Vaterite, like aragonite, is a metastable phase of calcium carbonate. It means vaterite is also unstable in the surface condition. Vaterite is also metastable like aragonite. But in this slide, only one point is important for us. Okay, vaterite belong to hexagonal crystal system because calcite, aragonite, and vaterite is the part of the polymorphic series. So crystal system is important for us. Next, we are going to discuss the most important part of the video, objective questions. There is the spelling mistake, but this is the objective questions on the aragonite and vaterite. First question, aragonite is the polymorph of the which mineral? So first option quartz, second feldspar, third is the calcite, fourth is the gypsum. So which one is the correct answer? So correct answer is the C. Okay, aragonite is a polymorph of the mineral calcite. Next, vaterite is the stable at which temperature and pressure conditions? So high temperature and pressure, low temperature and pressure, high temperature and low pressure, high pressure and low temperature. So what is the right answer? So right answer is the B, low temperature and pressure. Okay, vaterite stable in the low temperature and pressure conditions. Which crystal system does aragonite belong to? So cubic, hexagonal, orthorhombic, and trigonal. So what is the right answer? Aragonite crystallize in the orthorhombic crystal system. Next, vaterite crystallize in which crystal system? So what is the crystal system of the vaterite? Hexagonal, monoclinic, trigonal, orthorhombic. So which one is the correct? So correct answer is the A, hexagonal. Okay. Next, which of the following has the highest stability under the surface condition? Okay, this is asking the surface condition. Okay, so calcite, aragonite, then vaterite, then dolomite. So which one is the most stable in the surface condition? So right answer is the calcite. Calcite is stable in the surface condition, aragonite in the high pressure condition. Okay. Next, aragonite has the more hardness of, so this is again very important. Hardness is the 2 3.5 to 4, 5 to 4, 6 and 7. So what is the hardness of the aragonite? So correct answer is the B. Hardness of aragonite is 3.5 to 4. Next, aragonite transform into calcite over the time due to. Why aragonite transform into calcite? Option A, due to the heat, due to pressure, due to humidity, due to thermodynamic instability. Okay, so what is the right answer? Right answer is the D. Aragonite unstable due to thermodynamic instability. Next question, which of the following is not a polymorph of the CaCO3? So calcite, aragonite, dolomite and vaterite. So which one is odd in the option? So right answer is the dolomite. Okay, and other three are the polymorph of the calcium carbonate. Next, which of these is the least stable polymer of the calcium carbonate? So which one is the least stable? Calcite, aragonite, vaterite, then dolomite. So which one is the least stable? So vaterite is the least stable polymer. Next, aragonite can help to remove pollutant like, so this is also important, arsenic and mercury, zinc, cobalt and lead, sulfur and carbon, and oxygen and nitrogen. Aragonite can help to remove which pollutant? Okay, so correct answer is the zinc, cobalt and lead. Next, the bioreference value of the aragonite approximately 0.005, 0.055, 0.155, 0.300. So which one is the correct answer? Correct answer is the C, 0.155. This is the bioreference value of the mineral aragonite. Next, aragonite form under which of the following conditions? Low temperature and low pressure, high temperature and high pressure, low pressure and high temperature, high pressure and low temperature. So aragonite we already know form in the subduction zone, or this condition is the high pressure and low temperature conditions. Okay, this is very important question. Now aragonite is most commonly associated with which type of the metamorphic environment? Number one, contact metamorphism, regional metamorphism, okay, hydrothermal metamorphism, then subduction zone metamorphism. Okay, so correct answer is the D, subduction zone metamorphism. Next, which of the following best describe the aragonite compared to calcite? Okay, so low density, lower pressure form, same structure, different chemical composition, higher pressure polymorph of the same composition, completely unaltered mineral, higher pressure polymorph of the same composition. Okay, which of the following best describe aragonite compared to calcite? So aragonite is the high pressure polymorph of the same composition. Next question for you. Okay, which of the following type of the twinning is commonly seen in the aragonite? Spinel twinning, Carlsby twinning, cyclic twinning and basal twinning. So right answer please write in the comment section. Okay, so thank you so much for watching this video. Try to share this video with your geology friends. Thank you.